One of the first things you notice when you jump into the ocean is how salty it is. How exactly the ocean got so salty is a story we'll want to relate when we're back at our home base. And to do that, we're going to take a close look at the water samples we've collected throughout this film. Besides the water, the H2O itself, it's possible to see that all of these samples carry other matter, and they do so in two ways. First, all of these samples carry suspended particles. There are bits of soil and organic detritus. And there are even a few very small pieces of rock, minute objects that we refer to as grains of sand. Clearly, there are many more in this sample we collected from the muddy Amazon, but this Niagara water has similar particles as well.
After we leave those samples entirely still, as we've done here, you can see that nearly all of those particles have settled to the bottom of our jars. That is exactly what happens when the moving water from rivers flows into lakes. Once the water starts to settle down, the suspended particles sink to the bottom. That is what geologists call sediment. And not only does this collect at the bottom of lakes everywhere on the earth, the deposition of sediment occurs on a very large scale, wherever rivers spill out into our oceans. That is what makes up what are referred to as river deltas. Phenomenal amounts of soil are carried by rivers all over the world and poured into the oceans. But besides the soil bits that have now settled out, there are many molecules that remain in the water as long as it stays liquid. And that, too, is a consequence of that happens when water runs across the land. So let's see what happens when the water evaporates away. To do this, all we have to do is wait. Even if left alone, the water would gradually disappear over time. But to speed this up, I'm just going to add a little bit of heat. And when this happens, an important point to recognize is that only the H2O molecules themselves evaporate away. Any heavier ions that are dissolved in the water are left behind. So now let's picture our lakes and rivers. As we have just seen, there are trace amounts of salt in those waters. We do not detect it. It does not taste salty to us because the amount that is dissolved by rainwater is so low. And it remains low because the same amount of salt that does dissolve also flows downstream. But now, picture the ocean. Rivers all over the world are constantly flowing into the oceans. And every day they are bringing very small amounts of dissolved salts with them. And every day the combination of the sun beating down and the wind blowing across the surface causes H2O molecules to evaporate off into the air to form new clouds. Now picture this going on for thousands of years. No, even longer than that. Millions and millions of years. More than 4 billion years. That is how old the Earth is. And that is how long rivers have been gradually washing small amounts of salt from the rocky land down into the sea. And that is how long H2O molecules have been evaporating away, leaving the salt behind. 4 billion years of water and salt flowing in, and 4 billion years of water only evaporating away. No wonder the oceans are salty.